Hi, sixth graders, and welcome to our next sixth grade math class. Today we are doing Unit 8, Lesson 6, and we're going to be looking at area in the coordinate grid. As always, to build our habits, we're going to start with expectations. The first is that today you will need a piece of paper and a writing utensil to solve out your math. You will also need your classwork, which is in your Google Classroom. The second is please ensure that you are in a distraction-free zone, your phones are away, and you are in a quiet space. Pause the video and take 10 seconds to have your materials out and your space distraction-free now. The next is expectations for work. Please make sure you are getting all notes down on your paper and you are typing everything you need to type into your Google Classroom. And as always, remember that your handwriting should be neat and organized. Before we jump into today's lesson, I want to review where we've been and where we are going. As you know, our last lesson, we talked about finding the area in the context of real-world problems, and that's going to be directly applicable today, so I'm excited to see what you remember from that lesson. Today, we're talking about area in a coordinate grid, and our future lessons are going to be more complex area problems that involve shapes that are even more challenging than the shapes that we've worked with thus far. And with that, we are going to jump into a problem for today. Our problem that we're going to model together is on my screen. It is also in your Google Classroom doc. It says, Gerard created a map of his backyard using the coordinate grid below. Each unit represents 1 foot. He is planning on putting a rectangular garden in with the corners of the garden located at -5, 3, -5, -6, 5, -6, and 5, 3. How big will his garden be in square feet? Now, the first thing I need to do when reading this problem is actually identify what is this question asking me to do. I know that it's asking me how big my garden will be in square feet. And I know from our lesson yesterday that anytime I am covering the surface of a two-dimensional object, I am finding the area. So I make sure I annotate my problem as you see here with I need to find the area. Next, let's look at what this looks like on a grid. Typically in a math classroom, you would be plotting these points on your own on a grid, but given that we're working on the computer, that work actually is going to already be done for you in your classwork, so all you need to focus on today is actually solving. We have the same problem here on the left of the screen, and on the right you can see my coordinate grid. The first thing I need to do is actually plot these points. When I plot these points on my coordinate grid, using what I know about traveling horizontally for my x value or my first value, and vertically for my y value, my second value, I plot the points on my coordinate grid and I see a rectangle that looks like this. Now, what makes today's problem different than future problems is I'm actually not given my length and my width. But I know that the formula for the area of a rectangle is length times width. So I know I need to use what I know about distance on a coordinate grid to actually find my length and my width. I could do this by simply counting the boxes. I also know, based on our unit in absolute value, that I can find the distance between 2 points on a coordinate grid by either adding or subtracting my absolute values. As I look at the length and the width here, I see that my coordinates are in different quadrants, which means I need to add the absolute value of the coordinate that is different. Pause the video now, take 30 seconds on your own to see if you can identify the length and the width of this rectangle. Now I'm going to show you what I got as the length and the width and how I used absolute value to help me find it. On the top, you can see that I added the absolute value of -5 and 5 because the x coordinates were different. I know the absolute value of -5 is 5, so I got a length of 10. With my width, I noticed that the y coordinate was different, so I added the absolute value of -6 and the absolute value of 3 to get a width of 9. My last step is actually solving to find the formula. Take 10 seconds. You should be able to do this in your head, but you can also use your paper. What is the area of this rectangle? Take a look at how I solved. Length times width equals 90 feet squared. Remember your units. You need to have feet squared as your unit since this is area. And then I write an answer statement. Gerard's garden will be 90 square feet. Now again, I want us to think about what made this problem different than previous area problems. And that was that I needed to use my knowledge of a coordinate grid to actually solve this problem. That brings us to our key point for today. Area can be found on the coordinate grid by identifying the dimensions and applying a formula. Pause the video and copy this into your notes. Now we're going to look at another problem together that actually involves a different shape. This is also in your Google Classroom classwork. Now we are going to look at another problem together. This problem is also in your classwork on Google Classroom. It says, the coordinate grid shown represents a map of a park. A portion of the park is going to be a flower bed with tulips and roses. The portion of the park that will make up the flower bed has the following coordinates. A, -4, 4. B, 0, 4. And C, 3, -2. How many square units of mulch are needed to cover the bottom of the flower bed? Pause the video and take 30 seconds on your own to read and understand this problem. What is this question asking you to do, and what concept are you going to apply to this question? Take a look at my annotations here. I annotated the bottom as I need to find the area, because I know I need to find the area when I'm covering a two-dimensional shape. If you got that right, you made sure you were paying close attention yesterday, and that's really awesome work. Now, the next thing I need to do is plot these points. Again, I'm going to do that for you. And if you're uncomfortable with plotting points or you think you might make mistakes, you should let your teacher know so that you can get some extra practice. Hopefully you guys are masters at this because I know you guys have already learned how to do this in both 5th and 6th grade. As you can see, when I plot the points, they look like this. And when I connect the lines, I actually form a triangle. This is an obtuse triangle because it is an angle that is larger than 90 degrees. The next thing we need to do is actually figure out the dimensions. But before we do that, we need to write down the formula for the area of this shape. Pause the video and take 10 seconds to write down the formula for the area of this shape. If you wrote area equals 1/2 base times height, you are exactly right. Now it's our turn to actually figure out where are the base and the height on this shape. This is a little tricky, so I'm going to give you 2 options to vote on. A lot of people that solve this problem think that where I wrote base 1 question mark is the base. Others think that where I wrote base 2 question mark is the base. Which do you think is the base that we are going to use to solve this problem? When I say go, your teacher is going to pause the video, and I want you to show a 1 or a 2 based on which one you think the base is we're going to use from this problem. Pause the video and show your teacher. If you said base 1, you were exactly right. And the reason why here is a little tricky. We actually don't yet know how to find distance on a coordinate grid unless at least one of the coordinates are the same. As you can see in points A and C, my x-coordinate and my y-coordinate are both different. So I cannot use my knowledge of absolute value to find the base. But as you see in points A and B, they share a y value of 4. That means I can use my knowledge of absolute value to find the distance between A and B. Now we've identified the base, the next tricky part here is the height. Again, we need a set of coordinates that share a value, either x or y. And our height also has to be the vertical distance and be perpendicular to our base. So I actually identified my height right here. It's a little tricky because it's actually not part of the triangle, but it's the vertical height of the triangle, the distance between the base of the triangle and its third point. Now that we've identified both the base and the height, you're going to pause the video, take 30 seconds to actually find what the base and the height are, and then substitute it in to find the area. Let's see if you can all get the right answer. 30 seconds, pause the video, find the area now. Take a look at my work here. Notice how I found the base and the height were 4 and 6. When I substituted that into my formula, I got 12 square units. If you got an answer of 24, you made a mistake of not multiplying by 1/2. Anytime we're finding the area of a triangle, we must multiply by 1/2. Now remember, our key point from today was that we can find the area in a coordinate grid by first finding the dimensions. I did that in this problem by using absolute value to find the base and the height. Now, when you're solving all of your problems today, I want you to keep the following CFS in mind. First, annotate as always. Second is figures drawn accurately and labeled. This is actually going to be done for you in your classwork. Because it's really hard to actually identify points on a computer, we want you to spend most of your practice time in actually identifying the dimensions and finding the area using the right formula. Third is write your formula after you have identified your shape. Remember, you might see rectangles, triangles, trapezoids, or parallelograms today in your classwork. The next is dimensions are identified. Use your absolute value and what you know about the coordinate grid to identify your dimensions before you use your formula. All calculations are shown, neatly organized, and labeled as always. And lastly, answer statement is provided. Your teacher is now going to give you more instructions about what they expect from you during your independent practice. That's all for our video today. I look forward to solving even more complex geometry problems with all of you in our next lesson.